Have you ever wondered how the gasoline in your car is made from crude oil and the complex process behind its production? In this video, we're going behind the scenes to explore the fascinating journey of how petrol is made from crude oil. From the drilling rigs of Texas to the refineries where crude oil is transformed into gasoline, we'll uncover every step in this critical process that fuels the world. Whether you're curious about the science or the logistics behind gasoline production, this video will take you on an eye-opening adventure. Before we dive in, don't forget to hit the like button, subscribe, and ring the bell so you never miss out on more fascinating insights into how the world works. Every day, around 800 million vehicles around the world consume an astonishing 7 billion liters of fuel, ensuring that gas stations are constantly stocked with gasoline. Yet the process that keeps these stations filled with this highly flammable liquid is not only incredibly complex but also potentially dangerous. Have you ever wondered how gasoline is made and where it all begins? Let's take a journey through the oil industry in Texas, one of the world's key players in oil production, to discover how crude oil is transformed into gasoline, ready to power vehicles across the globe. The origins of oil. Texas is one of the most influential places globally when it comes to the oil industry. The state has been the backbone of U.S. oil production since the late 19th century, with the first significant oil drilling operations beginning in 1894. However, it wasn't until 1901 that the U.S. oil industry truly took off. That year, a single extraction company managed to triple the country's oil production overnight. Since then, over 60 billion barrels of oil have been extracted from Texas, and the state still holds vast reserves, with an estimated 10 billion barrels of oil still untouched beneath the surface. The U.S. oil industry is not only essential for fueling vehicles, but also plays a key role in providing over 50% of the nation's energy. Beyond fuel, crude oil is also responsible for producing petrochemical derivatives, which are used to make everyday products like plastics, tarmac, tires, cosmetics, and pharmaceuticals. This sticky black liquid known as crude oil is the raw material that will eventually be turned into gasoline. The formation of crude oil. Nature's work over millions of years. Crude oil is created deep within the earth over millions of years. It starts with the remains of plants, animals, microorganisms, and tiny creatures that once lived in seas and oceans. These organic materials settled onto seabeds where they were buried under layers of sediment. Over centuries, heat and pressure transformed this organic matter into crude oil, which is often referred to as black gold due to its value in energy production. The process took millions of years, and the crude oil formed is now one of the most important energy sources on the planet. This process, which started around 250 million years ago, is what makes Texas's oil reserves so precious. Drilling for oil in Texas. The hard work of extraction. In the oil fields of Texas, the process of extracting crude oil begins. The task is far from easy, as oil deposits are often buried deep within the earth, sometimes at depths of up to 4,000 meters. To extract it, oil companies use highly sophisticated equipment and technologies, including seismic technology, to identify potential oil reservoirs. Oil companies like Occidental Petroleum drill an average of one new well every day. Once a site is identified, drilling begins. The drilling process itself is a high-risk venture. The teams work with massive engines that use diamond-tipped drill bits to penetrate through layers of rock, sometimes as old as 542 million years. This is no easy task, as the friction generated by the cutting head creates a tremendous amount of heat. To mitigate this, water is continuously pumped under high pressure to cool the cutting head and carry debris to the surface. The drilling process is complex, requiring the drill's pressure to be carefully managed. Too little pressure and the drill won't cut through the rock, too much and the drill could break. Additionally, there is a constant risk of gas emissions, which, if ignited, could cause catastrophic explosions. As the drill digs deeper, sections of drill pipes must be added manually, and a 5-ton automatic dual wrench is used to ensure the drill continues to cut through rock at a rate of around 5 meters per hour. This process is repeated 24 hours a day, and at any given moment, over 2,000 new wells are being drilled in Texas. the journey of oil from the ground to the refinery. If the well proves to be productive, crude oil begins to flow up through small holes in the pipe and is transported to the surface. At first, the pressure from the trapped oil forces it upward, but this pressure diminishes over time. To maintain the flow of oil, oil companies use plunger pumps to push the oil to the surface. For deep wells, the plunger pump works like a giant syringe, using the engine's flywheel to convert circular motion into vertical motion that helps draw the oil out of the earth. Once extracted, the fluid from the well, which contains not just crude oil but also carbon dioxide, hydrogen sulfide, and natural gas, travels through pipelines that eventually lead to a gas removal container. Oil transportation, from Texas to refineries. The next challenge is transporting the oil. Crude oil needs to be moved from the drilling fields to refineries, which are often located far away from the oil wells. In Texas, a series of massive pumps push the crude oil into pipelines that stretch for over 1,000 kilometers, making its way to large oil refineries for further processing. One of the largest refineries in the U.S. is located in Texas and covers over 10 square kilometers with more than 8,000 kilometers of metal pipelines. This refinery can process over 562,000 barrels of crude oil every day. It is so massive that it doesn't just process Texas's crude oil, but also imports oil from around the world. The noise in the refinery is deafening, with over 4,000 workers using ear protection every year due to the loud machines. At the refinery, crude oil goes through a process known as fractional distillation to separate the different types of hydrocarbons present in the crude oil. Fractional distillation, the heart of the refining process. Crude oil is a mixture of hydrocarbons, which are organic compounds made up of hydrogen and carbon. Each hydrocarbon has a different number of carbon atoms, and the size and weight of these molecules determine how they are separated during the refining process. For example, propane is the lightest hydrocarbon, while the heaviest ones are used to create tarmac. At the refinery, the crude oil is heated to over 370 degrees Celsius and then pumped into the base of a distillation tower. The heat causes the oil to evaporate, and the vapor rises through the tower. As the vapor cools, the heavier hydrocarbons condense first, settling at the bottom of the tower. Lighter hydrocarbons, like gasoline and kerosene, continue to rise and condense at higher levels, where they are siphoned off. For every 191 barrels of crude oil, approximately 88 liters of gasoline, 48 liters of diesel, 26 liters of kerosene, 7 liters of propane, and 32 liters of other products like lubricants and plastics are extracted. Testing gasoline, ensuring quality and performance. Once gasoline is produced, it undergoes a rigorous testing process to ensure it meets the required quality standards. One of the most critical tests is conducted in a specialized engine designed to assess the fuel's resistance to knocking. Knocking, also known as engine knock, occurs when the fuel ignites prematurely due to excessive compression in the engine cylinder. This premature ignition can cause damage to the engine, resulting in decreased performance, efficiency, and potential long-term harm to the vehicle. The engine used for this test is designed to simulate real-world conditions, allowing technicians to monitor how the gasoline behaves under varying levels of compression. The primary goal of the test is to measure the fuel's octane rating, which reflects its ability to resist knocking. Gasoline with a higher octane rating is less likely to ignite prematurely and is better suited for high-performance or high-compression engines, ensuring smooth and efficient operation. By conducting this test, the refinery ensures that the gasoline produced will perform optimally in a wide range of vehicles, from everyday cars to high-performance sports cars. This quality control step is essential in maintaining the integrity of the fuel supply and minimizing the risk of engine damage for consumers. Additionally, refining processes may be adjusted if the gasoline fails to meet the necessary standards, ensuring that only top-quality fuel reaches the market. Transporting gasoline, filling the tanker trucks. Once gasoline successfully passes quality control, the next step is its transportation. Gasoline is typically transferred through underground pipelines to nearby distribution terminals, which serve as key hubs for fueling stations. From these terminals, gasoline is loaded into large tanker trucks for distribution across the country to gas stations, where it will be dispensed to consumers. While the process of loading gasoline into these tanker trucks may seem straightforward, it's a high-risk operation that requires extreme caution. Loading gasoline into a tanker truck is far more hazardous than filling up a car's fuel tank. One of the biggest dangers is the risk of explosion, which can occur if any mistakes are made during the loading or unloading process. Gasoline is highly flammable, and a small spark or mishandling can lead to catastrophic consequences. Static electricity, which naturally builds up during fuel transfer, is one of the most common causes of accidental ignition. If not properly managed, static can generate sparks, which could ignite gasoline vapors in the air. To minimize the risk of such accidents, strict safety measures are followed. The tanker truck is first grounded by attaching a cable to it. This step prevents static electricity from accumulating and eliminates the chance of sparks being generated. Protection sensors are also activated to ensure the tanker is not overfilled. These sensors are crucial in preventing accidental spills or overflow during the loading process. Additionally, a vapor recovery system is employed during the transfer. This system captures any gasoline fumes that might escape during the loading, preventing them from being released into the atmosphere. These measures are essential for maintaining safety and preventing environmental contamination, ensuring that the gasoline is safely transported to its final destination. Thanks to these precautions, the fuel can be safely delivered to gas stations and ready for use in vehicles. The final step: gasoline at the gas station. Once the gasoline has been carefully loaded into tanker trucks at the refinery, it begins its journey to gas stations, where it will ultimately be pumped into large storage tanks. Each day, approximately 4 million liters of gasoline are transported to various gas stations across the country, ensuring a steady supply for consumers. The journey is an essential part of the distribution process, taking the refined fuel from the refinery to locations where it will be made available for drivers to fuel their vehicles. The tanker trucks used for this transportation are specifically designed to safely carry large quantities of gasoline. They are equipped with multiple safety features, including grounding cables to prevent static electricity from causing sparks, and vapor recovery systems that capture and contain any potentially harmful fumes released during the transport process. These precautions are necessary to prevent any accidents, as gasoline is a highly flammable liquid that requires careful handling. Upon arrival at the gas stations, the gasoline is transferred from the tanker truck to large underground storage tanks. These tanks are carefully monitored and maintained to ensure the gasoline remains safe and clean until it is dispensed. Gas station employees follow strict procedures when unloading the fuel, including checking for any leaks or issues with the equipment. The next time you pull up to a gas pump, take a moment to consider the journey your fuel has taken. From deep beneath the Earth's surface, through the complex refining and testing process, and across miles of road to your local gas station, gasoline goes through numerous steps to make it ready for your vehicle. The labor behind gasoline production. It's important to remember that the gasoline we take for granted comes at a significant cost. The workers who extract, refine, and transport this essential resource work tirelessly, often under hazardous conditions, to ensure that we have fuel for our vehicles. Their dedication and hard work make it possible for us to fill up our tanks and drive across the country. If you've ever wondered how gasoline is made and transported, hopefully, this video has given you a deeper understanding of the complexities involved in the production process. Now that you know the intricate journey gasoline takes from crude oil to your car's fuel tank, it's amazing to think about all the processes involved in producing the fuel we rely on every day. From deep underground extraction to the meticulous refining process, each step is essential in delivering a high-quality product. Next time you fill up, remember the complex journey that fuel has traveled. If you found this video insightful, make sure to give it a thumbs up and share it with your friends. Don't forget to subscribe and hit the notification bell to keep learning more.